So, really quick note. First off, I wanted the test to be tomorrow. Obviously, we had 4 people absent today. They'd be at a major disadvantage to take that test tomorrow. That's their fault, right? And then there's several of y'all that still need to finish the demonstrate understanding. So, we will grade the demonstrate understandings today. We'll go over it tomorrow. Exam or test will be on Monday. And we'll basically use today and tomorrow to go ahead and start the bivariate data unit, which I know is Josh's least favorite, and I apologize, but I feel like that's going to be the best overall. Plus, on the actual AP exam, you're going to have to keep things separate and straight and know those things, just because early on. Huh?
That'd be my least favorite.
Early on, I don't remember, it was one day where I was like, oh, we can start the next unit, and you were like, oh no, I hate that. And I was like, okay. Don't worry about it. Yeah, it's fine. All right, mock exam, real quick notes. What time do you need to be here on Saturday?
8 o'clock.
8 o'clock, before 8, because we need to start at 8. Remember, I will have chicken minis here. Don't oversleep, Joseph, because I know you still have to make up that ACT, and we don't want to do that. But I'll go ahead and tell you this, what I decided to do is I went ahead and, assuming everyone's going to show up for the mock exam, so I'll take the points out if I need to, I did 20 free points, meaning it was a grade out of nothing, and so those 20 free points just went into your total grade, okay? So hopefully that went in before the progress reports. If it didn't, I'll sign off on your updated grade tomorrow, okay? So that's mock exam. Sound good?
Yes, sir.
So we're going to show up tomorrow. We're going to take that mock exam, except for Austin, because he'll have already taken it. On that note, I want to point out or Saturday morning, you know what I meant. So Austin has only taken the multiple choice portion. I just want to show you all this, because I finally found this. And so here, that's not what I want. There it is. So here is how the scoring works for the AP exam. Every multiple choice question is worth 1.25 points out of 40, giving you a total of 50 points. Each point on the free response is worth 1.875 points, and that's the true, because it adds up to 100 points.
Oh, makes sense.
So that's how they did it. The question 6, which we have not done one yet, so don't sweat it. We will review before then. Do your best with question 6. I'll give you some information before the mock exam starts about it. Is worth a little bit more. But what I want to point out is you just sum those two scores. They're both out of 50. Multiple choice is 50. Free response is 50. Just off of his multiple choice, what did I say, 35? Mm. He's already at 35 points just off of his multiple choice. He is 9 points away from a 3. And he is, what, is that 24 points away from a 4, right? So if he just gets half the points on the free response, he's looking at a 4. Any more than that, and it's looking good. So note, right, getting just half of the points on the AP exam gets you that 3. Getting 60% is a 4, right? So that's very doable, right? And I do want to commend Austin. I've noticed like the last week, 2 weeks, you just worked harder, right? And it's starting to sink in more. We got 2.5 weeks. You're all capable of getting that 3. Let's make it happen. And by all of you are capable of getting that 3, quite a few of you I'm expecting 5s because I know what you're fully capable of. So I want to see 3 to 5s for all of us. All right? Let's make it happen. Let's engage. Let's learn. Let's grow. All right. So don't be scared. Put in the work, and I promise you, I'll get you there. Demonstrate understanding analysis, that's tomorrow. So today we're focusing on what are called scatter plots in correlation with 2 variable data. Have you logged onto a calculator yet? Fix that. Let me see yours.
What's the username again?
Hold on, I need to get another one.
United Works, that's
Yeah, it's
I actually don't.
I keep meaning to just keep that one separate, and I keep forgetting.
Right, it doesn't work like it's just
I'll turn my caps lock off.
So if you look at where it says shift, you see in gray it says caps above it. So you hit Control Shift.
Like it wasn't that bad last week.
And now the caps lock's
3
on.
weeks piled up together.
Okay.
Oh, actually,
Are we going to be allowed to take these calculators to do the progress check later, or do you need them?
Yes, you can take it if you need to do the progress check.
Alright.
It's loading.
Okay. That's not what I need.
Oh, that's my name. Hold on.
So you should get this file once you log in. And so remember, yesterday we talked about, and we actually did the calculations of, or the one variable statistics. So let's go ahead and do that really quickly. If I were to get one more random person to grab candy out of the bowl, how many should I expect them to grab? What do I need to calculate? The mean, right? So let's practice this because you're going to need this for the AP exam. So what do we do to do cool crap? Menu, right? You're going to want to go to stats, right? Under stats. Not two variable yet, so stat calculations. Let's just do the one variable statistics for now, okay? So just run the one variable statistics. Number of list is only one.
Looking at candy grab.
And just the candy grab, right? I just want you to calculate the statistics for the candy grab.
You don't do a category list, right?
No. No, that is for categorical
I
data.
said data loss.
Well, okay.
What
Sorry.
if we fill out?
Hold on. I should have pointed this out. Pause, pause, pause,
I
and
have
look.
to change the result.
Yeah, you have to change the
column
result.
Yes. So if you did not hit Control Z, because your calculator is just like a computer, and that's the undo shortcut, right? So if you accidentally deleted info, actually I can show you how to fix it. Just don't sweat it. But first result column should go in column D, because we already have 3 columns. So if you didn't do that, let me know. Nope, that's right. You're good.
Do you need to write this?
Put handspan back in here, and then rerun it.
We just put
Yes.
Does
Does that make sense? All right, do we all get our calculations?
Yeah.
Yes? So how many should I expect the next person to grab?
21 is like
No, not 22.
21.7.
21.7143. I know it's a decimal, but if it asks on the AP exam, hey, what do you expect? Then you do the average, right? Like the expected amount is the average. And so even though, can you actually grab 21.7 candies?
You can like
Not literally, not in the real world, but that is what we expect because it is the average,
Shouldn't
okay?
expect that's unrealistic.
That doesn't work.
Say again.
Unrealistic expectations right there.
Right, but that's the statistics side of it. What's going on? Okay.
No, I don't know. Wait, it keeps on saying that. Oh, wait.
However, we discussed and we talked about it yesterday, is they're only the data that we want to consider, just the candy grab. No, something predicts it, doesn't it?
Yeah.
The handspan. So, let's learn how to create a graph for 2 variables like this, right? So what do I probably need to create to graph this data?
A graph.
A new page.
Okay, I need a new page. Which page though?
Graph.
No, data and statistics. Graphs are for your functions and your relations and your standard math, but we are not doing standard math. We are doing what? Statistics, right?
Okay.
So, quick question. Notice right here how each of these data points has a name to them, right?
Yeah.
Mine's different from yours.
Yeah, it's fine.
So I think
For now.
probably handspan on X, maybe candy grab on Y.
Why would handspan go on the X, Josh?
That's the outlier variable.
So, in that independent variable, what's another word for that in statistics? Independent or...
Positive.
Yes, but there's an E word we used. Explanatory, right? Think about the experiment side of things, right? There's the explanatory variable. It's explaining what? So put on the x-axis your handspan.
Explains.
Put on the y-axis.
It explains the Y variable.
Okay. Explains the y variable.
Y-axis, you put the candy grab.
Say again. Y-axis is candy grabbed. Yep.
It won't let me change it to a scatterplot.
Interesting.
You don't have to change it to a scatter plot. You have to click on the y-axis variable.
I moved
There-
it. Wait, I moved one. My bad.
There's a potential
Yeah, it's already a scatter plot.
I know what a scatterplot looks like. Right?
So, say again.
There seems to be a potential outlier.
Which one do you think is a potential outlier?
Bryson?
What do you think?
That's not an outlier. That would be
potential outlier.
I said potential outlier, yeah.
I don't know that I would call it an outlier.
It would be, an outlier would be like someone that's like not on the like expected line.
Ah, so does anyone know what we call that expected line? So like, and we're going to talk more about this in a second, but you see how I could draw a line that is approximating those data points?
Yeah.
So is that data point actually far away from the line?
No.
No. It does have a name to it, but it wouldn't be an outlier, okay? So we're going to talk about those soon, so hold on to that. But notice, there's a line that is approximating those data points. Does there seem to be a pretty strong linear relationship between your hand span and how many candies you're grabbing?
Yeah.
So
You can
we need to
actually
talk
add
about
a
should be.
line to that too.
Say again?
You can add a line to it too.
Like on the calculator?
Yeah.
Yes, we're going to do that soon. Hold on to that. Yes, Logan?
So if someone's hand was like really small and they grabbed a lot, then that would be an outlier.
Possibly. So if their hand span was here, and let's say they managed to grab 27, would that be far away from what we expect?
Yeah, that makes sense. I was thinking more like a
Yep.
dot plot.
Yep.
Like a one
You can make a
variable
sentence.
line.
Why he's the quarterback and
That
can
is
call the
true. I guess
football.
that
What?
makes sense.
I was thinking like a one variable dot plot, I guess.
Correct. And so we're going to talk about that. So hold on to that. Guys, y'all are thinking statistically, and I love it, right? So hold on to all these ideas.
Can we make a centimeter to star-verse ratio?
Maybe.
I think that's-
Maybe we're going to look at that soon.
Are you actually?
Oh, look at that. It's like we have statistics to learn. So candy grab activity revisited. So notes, right? What should we make a note of that we have already learned from this candy grab activity?
Linear.
That Bryson's.
Bryson's crazy, but like beyond that, come on, think about the statistical side. What have we learned so far?
There's another linear.
I might open it much.
But how do we get a linear correlation?
Because it looks linear.
But how do we get something that looks linear?
Because the
Scatterplot.
Correlation.
Variables.
So there is, but we created a what, Deacon?
Scatterplot.
Okay, but what is a scatter plot?
It's
A
Plot, like dots, plot,
representation of the data.
it's just a representation of the data.
Yeah, but how are we getting those points? It's not random.
That's
Make an order pair.
So we're making what?
Order.
Ordered pairs between an independent and dependent variable, right? So a scatter plot is a, by the way, so how many variables do we have with a scatter plot? Oh, we have two. What type of variables?
X and Y.
They are independent, dependent, but think about your flow chart. There's two,
Categorical.
quantitative or categorical.
Wait. Quantitative.
They're quantitative. Isn't the X numbers and the Y was
I
numbers?
say quantitative. Yeah.
Yeah. So a scatter plot is a graph of pairs of quantitative variables. Right?
Facts.
And so that's all it is, this graph of pairs of quantitative variables. And so we have how many variables?
Those two.
Two, right? And what goes on the x-axis? The independent, or what was the other word I used? Explanatory. We don't always use explanatory because it's not always clear which one explains the other. Sometimes you just have two variables, but one is definitely independent and one is dependent, right? But in this case, is there very clearly one that explains the other variable? Yes. So, graph of pairs of quantitative variables, and so it goes independent, comma, dependent. And so sometimes we're going to call that independent what? Explanatory. Well, it's always an X, right? Dependent would then be called close.
Reactive.
Think about experimental design, explanatory and response, right? Don't your science teachers still teach dry mix, right?
It confuses me so much more.
So your response is your manipulated or independent variable? Isn't that what the R stands for?
I barely passed it.
Don't worry about it. I think I was just trying to make a connection, it's fine. But notice, right, independent and dependent, right, explanatory and response, right? And so sketch of this, right? So when we look at the candies grabbed, You don't have to be super specific, but what would I graph here?
A line. No.
The book.
If I'm talking about just the scatter
Oh,
plot?
just the points.
Just the points, okay, so what do I need?
An x-axis.
Axes.
I need, oh, what do we need?
Lust.
Ah, we need to make sure this graph is lusting, that's right. So what do we need here?
A label.
Labels, what's my labels?
Your axes.
Okay, so what would be here?
Oh, your,
Hand span, there we go, okay. What needs to go here? So candy's grabbed. Alright, we got our labels. What else do we need? Units.
Centimeters and.
So centimeters.
And number of candies.
And so number of candies grabbed. Okay. What's next? Well, this is going to be my scale here. And I need you to pay attention to this. Did I start recording, hopefully? Yes, I did.
Like you want to start at like where roughly where the like, lowest hand span.
So usually when you make graphs, don't you usually start at 0 with graphs?
Yeah.
But in statistics, we want to focus on the data. And so we really want to start just a little bit below our lowest data value. So what was the lowest hand span? 16 and a half, so maybe around 16,
Mm-hmm.
and then 17,
Start
18,
where the data starts.
basically, yeah.
Can you skew the, scales, like, do they have?
Man, bump that, I'm not, because I had to go all the way out to what, 29? 28? So you have to have a steady scale, but I'm gonna go by 2s so that I don't have to do every single one. So you can go by 2s or 4s or hundreds, it depends on the data.
Do the y and x-axis always have to be the same?
No, they do not, great question.
I know in bio I used to be in trouble with that, so.
Nope. They do not have to be the same.
2 Ys.
So what's our lowest number of candies grabbed?
I don't remember.
You have it right there. It's 18?
18.
Okay, so 18 was the highest number? Like 30?
Yeah.
So 18, 20, 22, 24, 26, 28, 30.
How many did I grab?
Not many. You were the 18.
Oh, no. 0.
So,
That's okay, did you have my
yes.
new one or old one? That's what.
I don't remember.
I grabbed 23.
So, here's the thing, sketch out that graph. It doesn't have to be super accurate, but let's get our data points in there.
Also with you.
And so make sure you make that note. So again, I'm not going to be super hard on this. Hey, how about you focus on learning something? That's a wild concept.
Learning a lot.
That's good.
Nice, let's you graph.
That's what I'm saying. 21 and about 25.
So how do people get to the CTE building? Because they've.
You go outside through the gym locker room and you just go out the back to the
Okay.
back area to where Mr. Acker's class is at.
Alright.
Should we have to draw that?
So guys, draw a sketch because it literally says in the notes, right? Notes and sketch. So we should have a sketch of this. Make a note of, hey, when we create that graph, we got to make sure that graph is what?
Lusting.
Lusting still, right? That has not changed. It needs to have labels, it needs to have units, it needs to have scale, and then title.
Why isn't he a title? That's pretty lame.
Oh yeah, we didn't do a title yet, did we? What should we title this?
I said handspan versus candies grab.
Yeah, no, that'll work, right? I would have said candies grabbed based on handspan.
Yeah.
Any kind of title will work, as long as it's reasonable, right? By the way, did any of you want some,
Yes.
yeah. Okay, when we get up a little bit later, you can get some Starburst. I'll just set them here. Would it be more fun if I just started tossing them around?
Yes, sir.
No, I can't see.
You want to like straighten, you want to with the wrapper in your mouth? Oh, Ashton. There we go.
Smack
They're like right
that.
about it.
Alright, look.
You get some candy. You get some candy.
Orange.
You get some candy.
Oh, yeah, I want more.
Just
You get some candy.
people just like
And an orange.
Can I have more?
There's an orange.
a little boshy.
Wait,
guy,
throw
you
some
can
in.
like scratch him.
Huh? All right.
The air resistance.
But real talk, we gotta get
It's your
going.
fault.
Hopefully this
You're
was
going
a
so
little fun
fast.
stupidity. But Joseph, do you want any or not? You good?
No.
Joseph's too cool for Starburst. Got it.
He'll do it.
Just like school in general.
I don't know about.
Okay.
Give it. Give it.
So right here.
I'm not good yet.
Why do we study? Hey guys. All right. There's plenty of Starburst. Oh man, it's like we're seniors in high school. He stole my lunchbox. All right. Why do we study relationships between two variables?
So you can predict what other people should.
So it is a prediction idea, but remember, with one variable, we could make a prediction, right?
Yeah.
We could look at just the average, huh?
Not how one affects the other.
Right, but like, would we be able to make a more accurate prediction based on an independent variable? Think about it this way. So like, I just erased it, but if I just looked at the average, what was the average number of candies grabbed? Was it 20? 21.7. I want you to think about it though. Is that really close to all of my data values?
No.
No, right? I got 4 of them below and I got these 3 way above. So that's not a great prediction of what someone would be able to grab, but based on their hand span, I can make a more accurate prediction. See how that line is a whole lot closer to all my data points? And so that's the idea, is that when I have an independent or an explanatory variable, I can make more accurate predictions. That's the goal of statistics with 2 variables. With 2 variables, I can make more accurate predictions.
Thanks. Can you repeat that last part?
With 2 variables,
No, the justification for that.
I can make more accurate predictions.
Yeah, well, how?
Because
Oh wait, okay, that makes sense in my head now.
if we got that trend line in there, you see how that trend line is much closer to my data points?
Yep.
Yep, right. And that's actually going to be a very important part of what we study a little bit later with what's the standard deviation of those data points, with what's called the mean sum of squares and residuals and the whole nine. All right. So how is this chapter different from that section 1.1? That was that one variable statistics. Well, here we had no explanatory variable. We had no independent variable to help make a prediction. That's the whole thing. So what's the difference between explanatory and response?
Explanatory causes the response.
Okay, right? Very simply, explains these values, or these outputs, slash variable values. Okay? Now, again, I mentioned it earlier. Is there always a clear explanatory variable and a clear response variable? No. For example, could I create a scatter plot of someone's height and their ACT scores? Yes. Is there a clear explanatory variable in that case?
No.
No, right? There's not a clear explanatory variable. Also, do you think there'd be a high correlation there?
Not really.
Not really, right? So we need to study what makes a good explanatory variable, what makes a bad explanatory variable. Okay?
I mean, there could be a
And
correlation.
so say it again.
Could be.
There could be a correlation, right? Say it again. So, like, you're saying, but the correlation between someone's height and their, whether they play a sport or their athleticness?
Yeah.
Could there be a correlation between height and athleticness? Or athletic ability? Oh, maybe on the ACT? So maybe that there is some relation there, but not always. So how do you know which variable to put on which axis of a scatter plot? So what goes on the x-axis?
X would be the independent.
X is my independent or explanatory. If there's a clear explanatory, it has to go on the x. If there's no clear explanatory variable, it does not matter the order. So let me say that again. If there is a clear explanatory variable, it has to go on the x. If there is not a clear explanatory, it does not matter the order. So the y-axis would be my dependent or response. Okay? And we already talked about it. Where do you start each axis?
Right before your data starts.
So, and I would say right before, I should have said that, right before where the data starts. Okay. Any guesses what the easiest way to lose points when making a scatter plot is?
Don't
Not
bust
labeled.
it. Yep.
Yeah, if it's not lusting, then you done messed up, Aaron. So, if you don't get that reference,
I get that.
Go look it up.
They've got better stuff,
I mean, you're not wrong, but it's still a fun one.
Key and Peele are awesome.
I guess. I think it's another
You can possibly win.
You're not necessarily wrong. So,
Oh,
here
it's-
is the little
it's
link,
okay.
right? That's in the notes. I think we should give it another shot. We should break up and I can prove it. There's our relation. Oh, there. Can you hand me that battery?
Yeah.
Are you alright?
Yeah, it didn't hit me. That was just weird. It more shocked me. All right. Wow, nice. All right.
I feel like they did have.
You're talking about the document.
So, I'll worry about that later.
Yeah.
Miss Arliss, don't let me forget to put it up there. Okay. So there's our relationship, and he goes, huh, maybe you're right. I knew data would convince you. No, I just think I can do better than someone who doesn't label her axes. What does that actually mean? I don't know. If there's no labels on the axes, if there's no numbers there, if there's no scale there, if there's no title, that graph is crap. It is not worth our attention.
I don't know, it looks pretty bad to me.
What's up?
Since we're here, you know that sheet you gave everybody when you went into the classrooms?
Yeah,
Can we go over that meme on there? Because I don't remember it, but I want to know it now.
it's outside on the board out there.
Alright, okay.
There's one down, so I just assume it's bad.
What happened?
I don't even remember what's on there, but it's... What does it say, Deacon?
Hold on, let's get really close to that board.
That's true.
Deviations above the norm? What?
It says what?
Your 3 standard deviations above the norm.
Seriously, dude? You don't get that?
It means you're doing really good.
Yeah, I get it.
Okay.
I just thought it'd be better than that.
When you haven't taken stats, you have no clue what it means.
Yeah.
Now you do. You're
I wish I
welcome.
did.
Oh my gosh. Let me complain about one more thing. My name's Deacon.
Deacon, you were literally making like a
I don't think your name's
95%
Deacon, I think that's
confidence
false.
jokes the other day. Like,
Okay. What
I think those are better
pages?
than that crap. Okay.
What pages does it say in the notes? 152 to 159.
Oh, yes,
Okay.
it does.
So, right here, okay, so notice again, always look at the definition of the book. Deacon, can you hit the lights for us?
Yep.
So there's a little bit more context here that's always good to look at. A scatter plot shows the relationship between how many variables? 2 quantitative variables measured on the, what does it say right there? Same individuals, right? So it's 2 quantitative based on the same individual. That's why it's a pair. The values of one variable appear on the horizontal axis, the values of the other on the vertical. And so each individual in the data set appears as a single point, right? Remember, these textbooks are very, very, very useful. How to make a scatter plot. What do we see there? Label. Then scale. And when you do the scales, you have to have your units, and you always got to title it and then plot your data values. Nothing new there, right? Notice, Deacon, it does say under scale the axes, place equally spaced tick marks along each axis, beginning at a convenient number just below the smallest value of the variable and continuing until you exceed the largest. The axes do not have to be the same.
Right.
It works out well for this one to make them the same scale, right? But if I'm talking about months of the year and I'm talking about millions of dollars of revenue, am I going to go by ones on the millions of dollars of revenue? No, right? So,
Let's see that.
hopefully that explains it. All right. So describing a scatter plot. What do you think we would want to talk about with the? Actually, if we already.
Spread.
Yeah. So. Oh yeah. Easiest way to lose points is when we don't lust. 4 characteristics we should consider when describing a scatter plot. So when we look at this, what should we talk about with this data?
Line of best.
So first off, for it to have a line of best fit, the data needs to be what?
Linear.
Linear. So notice, if I had data that looks like this, would I use a line of best fit?
You can't be trash.
Parabola of best fit.
All right, you'd use a quadratic of best fit, so not a linear. So, but we need to talk about the what of that.
Red.
Well, we need to talk about the what first? The shape, right? The shape of it, okay? The shape is where you would want to start, and most of the time we're looking at what type of shape? Roughly linear, right? Now you said spread, right?
Yeah.
The way that we would talk about that with scatter plots is the correlation, right? How strongly, how linear is it, right? So there's linear, and then there's the correlation, how linear? You're really linear. Any other thoughts about what we would want to talk about with this?
Possible.
Residuals.
Maybe, let's talk.
Unusual aspect.
Maybe, but I want you to come. I'm just making up one right here. What's different about this scatter plot versus this one?
One's negative, one's positive.
Direction.
Direction, right? What do we consider this direction?
Positive.
Positive. This direction would be
Negative.
negative,
Facts.
right? So shape, correlation, direction. Those are the three big ones. Let's see what the book said about the fourth.
What'd you say correlation was?
Dang, you can't even
Not
abbreviate.
like how linear.
I know. There we go.
Skid.
Yes, it was the unusual features is the last one. So,
Oh, okay, sorry.
Yep.
Scud.
So two variables have a positive association, right? When values of one tend to increase the values of the other. So positive slope. Negative association when it's a negative slope. And sometimes there is what kind of association? None, right? If they do not help predict each other, then that's it. So right here on the AP exam tip, when you are asked to describe the association shown in a scatter plot, what are you expected to talk about?
Direction.
Form.
What is strength?
The form, linear or nonlinear,
Okay.
right? So the shape, okay?
Okay.
So linear, nonlinear. Strength, right? Notice what are the three words for the correlation or the strength there? So weak, moderate, or last one? Strong, right? So shape, linear or nonlinear. And we don't have to worry about anything but that on the AP exam. Direction.
Positive.
Up or down.
To the right, to the left.
Guys, it's right there.
Down.
Positive.
Positive,
Up.
negative, or
No.
none, okay? And the last one is unusual features. Always look for unusual features. And I will say this, you remember how we had a specific rule for outliers with one variable data?
Yeah.
We're not going to have a specific rule for that here, and so we're not going to call them for sure outliers, we're going to call them potential outliers, right? And so we will have unusual features. These are going to be known as potential outliers, or, does it say it here? No. Yeah, so
Clusters.
what we call them potential outliers, you can talk about clusters,
Distinct values.
influential points. High leverage points is the other one.
Those are like
Would
way,
Bryson's
way
be
off.
a high leverage point?
Correct. Bryson's would be a high leverage point.
Also, Mr. Can I have a question? Is this the next unit or is this unit?
This is the next unit. This will not be on your test.
Okay.
These wouldn't necessarily be like a potential outlier though, because it's still close to the line.
So it's close to the line, but do you think it might have changed the slope of that line a little bit?
Yeah.
Right, if I go back here, it probably would be close, but if I took out this data point,
You kind of follow.
it would probably be, well, see, he almost defines it though. If you take out this data point, the line that gets closest to those data points would be right here, wouldn't it? And so by having his, it's almost defining the line right there. So it's a high leverage point. It's changing what the line would be. Okay, but we're going to talk more about that. Don't stress it yet. So we got our 4 characteristics. How do we include the context? Any guesses?
Includes context.
But
I don't know what you mean by how, you
Because-
mention it.
so you need to use what?
So it's variable.
Both variable names in your description. You have to make sure you have both variables, and I would call one of them your explanatory, one of them your response.
What if you don't know? Which
One's your independent, one's your dependent. That you will know one is independent, one's dependent based on the way the problem is set up. Most of the time on the AP exam, they'll tell you independent versus dependent, or they'll have a graph that you're analyzing.
Alright.
Yeah.
Well, like, would you have to say explanatory or response, or could you just say independent and dependent?
Say that one more time.
Would you have to say explanatory and response, or could you also say?
You can always say independent, dependent, yeah.
Alright. So I feel like you wouldn't always be able to say explanatory.
Correct. And that's what we talked about. You can't always say it, but please always note here, even when there's a clear relationship between variables in a scatter plot, the direction of the association describes only the overall trend, not an absolute relationship. And also, if there is a high correlation or a high association, does that prove causation?
No,
Why not?
because you didn't assign here's the given
So it's not an
experiment.
experiment where we've reduced confounding. If you do an experiment where you reduce confounding with random assignment, with blocking, with all those things, can you establish causation?
Yeah.
Right. So keep that in mind. That's how we can establish causation, is by looking at that bivariate data with an experiment. So again, please use your textbook to help you study. It's very beneficial. And that's the first set of our notes. There's some homework problems there to help you apply some of those ideas and practice them. All right, correlation. Let's actually talk about what correlation is. So what symbol do we use for correlation?
R.
R, right? So notice that it's right there in the notes. Say again.
It's not Y.
Oh, I said why.
R.
Y. Yeah.
No,
So
why
we're gonna-
is it why?
Why is it R?
Yeah.
We're going to talk about it in just a second, actually. Okay.
R.
So, looking here, would you say that this has a high correlation or a low correlation?
Pretty high.
I'd say high.
Yeah, the high correlation.
It's a decently high correlation, right?
Mid.
So now we need to figure out, well, what numbers would we use to describe a high correlation? Because we know that there's these words, weak, moderate, or strong, but we want some numerical, statistical values to back those up, right? Yes, Mr. Kenny? Great, I'm glad we're all on board with that.
Yeah.
What pages does it say in the notes? 160, 169?
Yeah.
And so, I will say this. I mostly want you to, again, I want you to go back to the book. This book is a resource that you can always go back to and use, and it's useful. But notice right there, a correlation. What is it?
It is for linear association between two quantitative variables. The correlation measures the direction and strength.
So, really, I guess I should have not put this here. This will say strength. And so these two things are my correlation together. So the strength is weak, moderate, or strong. The direction's positive, negative, or none. And those together are my correlation, right? So the correlation measures the direction and strength of an association. What are some of those important properties?
Always negative 1 and 1.
It's always between -1 and 1. So I want to pause. I want you to think about this. Just as a guess, right? If R is -1, what do you think that's going to tell us about the correlation between those variables?
Weak. It's like negative.
So it's a negative, and it's actually strong.
Oh, shoot.
What would be a weak relationship or
Zero.
no? Ah, R equals 0 would be no association. Or at least, let me reword that, no
Correlation.
linear
So like.
association.
weak.
That's
You're saying
important.
Exactly -1.
So it's very rare you're going to have R equals -1 exactly, okay? But if R was -1, it would be a, and usually I put the strength first, so it would be a strong,
So like.
Linear.
-1 is 0.
strong negative linear relationship.
So it was 0.5 moderate?
Nope.
Great.
So 0.
I'm about to tell you, hold on. So strong negative linear relationship or association, if R equals 1, we're going to say that's a strong positive linear relationship, okay? So what were y'all asking?
Would R equals 0 be weak?
No, it would basically be none. No linear association.
So if it was
Or it'd be very weak.
0.01, would that be weak?
It'd still be weak. So hold on. Here's the rules, guys. If the absolute value of R, so whether it's positive or negative, is greater than or equal to 0.8, we're going to call that strong. If it's between 0.5 and 0.8, we're going to call that moderate. And if it's less than 0.5, it's weak. Now notice it says the absolute value, right? And so the reason why is that just means if it's a positive or negative in between those sets of numbers, that's how we know. So,
Wait, if it's equal to 0.8, but it's also equal to...
sorry, we'll just,
I was about to
I'll say this, it really doesn't matter, like it's never going to be exact. So, don't sweat that too much. Okay. Those are the general rules that we go along with. Okay, but notice these important properties here, right? Correlation is always between -1 and 1. If R is greater than 0, then it's what type of association? If R is greater than 0? Positive. If R is less than 0? Negative, right? And notice it's always indicating the direction of a linear relationship. The extreme values, -1 and 1, are only in the case of a perfect line, which will never happen. If the linear relationship is, by the way, do you know why this is never going to happen, really?
What? Just like the perfect circle.
Just like the perfect circle. It's not just that. What is the foundations of statistics? It starts with a V. Very, well, say variability, right? The foundations of statistics is that there is variability everywhere, right? And so we have to learn how to measure and basically harness that variability to make predictions about populations, to make predictions about cause and effect. So the whole point of statistics is learning how to harness the variability to know or make predictions. Yes? Nope, never again for the rest of your life. If the linear relationship is strong, the correlation will be close to 1 or -1. If it's weak, it'll be close to 0. Notice this caution here. It's only appropriate to use correlation for what?
To describe strength and direction of a linear relationship.
Linear relationships, right? Correlation is only for linear relationships, and it's just R. We are going to talk about something called R squared. It's called the coefficient of determination. You can use that for nonlinear relationships. Don't sweat it too much. It's not something that shows up very often. But I will show it to you later. But it should make you think about standard deviation versus variance.
Could you theoretically get R of 1 and -1 if you, or R of 1 if you use the same variable twice?
Yeah, but that's not useful information, is it?
That's just a
But you
single
still
point.
can-
A single point isn't
It's
a
like
line.
having 100%.
Yeah.
Exactly.
Yes.
Sorry, this is kind of unrelated, but the correlation and residuals and stuff was on like 4
I
other
know.
questions. So I
And
could
so
have
think
gotten
about
more if I
that. You
knew
could have
more.
earned even higher. All right. So here, though, does correlation imply causation?
No.
In order to establish causation, you have to have a what? Experiment. Right. So we should have the rest of this filled out. Make sure you have that note. So there's characteristics there. We want to have that filled out. The correlation imply causation. The answer is no. You have to have a or an experiment. All right. So instead of doing it individually for the sake of time, we're going to look at this applet activity together. I have to look back at what. So notice here are some examples to help you go ahead and start thinking about it. Notice here is a correlation R equals 0, negative 0.3. That almost looks like 0, but you see how there's a very slight line that could go through here, right? R equals 0.5, well that's why it's at 0.3 because it's very low. 0.5, still moderate to weak. Negative 0.7, you see how it's a more clear line. Plenty of scatter though. 0.9, more linear. And then negative 0.99. Even that is not perfectly linear, right? So there's that. All right, so here's the applet activity. So guess the correlation at rossmanchance.com. Let me pull it up. So guess the correlation.
Guess that correlation.
There we go. All right, so that is, why is it so tiny? All right, I'm gonna make it bigger so that one, everyone can see it, but also Deacon can see it. So, so let's have a discussion. Let's look at a sample of 25. What do you think that correlation is?
Like 0.7.
I mean,
I give
Ooh.
it pretty strong.
We're gonna go with a solid 0.8.
5.
You think it's a 0.8 with these data points down
Point.
here?
I'm sure.
We're like
0.7.
0.7.
0.55.
0.6.
All right, let's try
0.55.
0.6.
So good.
Way off.
I said
So
0.5.
notice, hey guys, it's just to help build some understanding of correlation, right? Notice, is that really a strong relationship that's
No.
linear? I can almost do like a horizontal line, right? If I can do almost a horizontal line, then that's a pretty low correlation. I can almost see it right here, but all right, let's do a new sample.
Can I get it?
0.02.
Can I get 0.1 in there?
It's like a 0.
Good with 0.1?
I got 0.3.
0.2.
Point.
Like a 0.
Oh,
Hey.
shoot. We suck.
Where's the fun?
Intriguing.
Hey, but here's the thing, and I do want to point this out. Is it a weak relationship like we guessed?
Yes.
I don't know how in the world that's a 0.4. I would have guessed 0.2.
Yes,
All right, here we go. Okay.
Negative.
0.7.
Negative.
Negative
You see this one data point right here?
Yeah,
but-
I think that's going to make it a little bit higher. Maybe a negative point
0.65.
86, 85.
Negative 0.65.
0.65.
Oh, negative 0.8. Okay. I almost said negative 0.8. Okay. So notice there's a decent bit of scatter, but what would we call this point more than likely? High potential, high leverage, right?
What if we did like more points?
Like a 7.
Oh yeah, it's a solid 8.
I'd say
Not gonna lie.
0.8.
0.8?
Solid 0.8.
Well, that's what
Let's try 0.8.
Put 7.
Oh
Okay,
yeah.
okay. 0.773. So we starting to see how these correlations kind of work,
Yeah.
right? So new sample.
Oh, yeah, that's like a
0.2.
I got 2.
4.
I got
0.5.
0.5.
0.5. Oh,
Okay.
I was pretty close.
No, it's off the graph, dude.
oh, shoot.
So what do you think?
That's a
Solid
crazy
point.
point.
7.7.
Alright.
So noticing, I want you to think about it. This is a good way to keep it in mind. Do you think that this is a strong, moderate, or weak negative
I
relationship?
think it's a
I
strong
would say-
negative.
Moderate.
I'm gonna go moderate. I could see negative 0.7. Let's find out. You might be right though.
Oh, sorry.
Wow, that's lower than I thought it would be.
Why is there one
Okay.
that's off the graph?
Yeah. All right, one last one, and then we're gonna move on.
I can do this all day.
Oh, negative 0.8.
Negative
So,
8 at least.
Definitely negative.
Negative.
Do we think it's a strong
It might
or
be a
moderate?
strong. It's strong.
It's
I'm
strong.
going like negative
8,
0.8.
yeah.
0.81.
2.
Oh.
Yeah.
All right, so we're starting to understand this idea of correlation a little bit better.
Yeah.
Starting to see it? Okay.
We should have took these standard deviations on all of our guesses. I think I class.
Say again, Josh.
Is there a formula for this?
Yes, there's always a formula, but it's an ugly formula. So you know what we're gonna do?
No.
Okay, use that calculator. Yeah. Okay.
Okay. Good.
So which association is more linear, with an R of 0.5 or an R of 0.9? 0.9. Okay. 0.9. Right. The closer it is to 1, the more linear it is. Does a correlation near 0 mean an association is weak?
Yeah.
No, it means
Not
no
necessarily.
I'm saying yes.
No, what kind of association?
Linear
It
association.
just means there's no linear relationship.
Ah.
So R equals 0 is no linear. Because if I were to graph this, right? Is there no association between those data values?
Nah, there is.
There's definitely an association, right? It's just not a what?
Linear.
Linear association, okay.
Is that what was on that back of that FRQ?
Yes, the scatterplot stuff
Oh.
that you were freaking out about. Yeah, don't worry about it. Is correlation resistant? Do you think
I'll say
No.
no.
It's affected by the leverage point.
it's affected by high leverage points? It's affected by outliers. Notice we talked about it before that if we were to just have one variable, we would look at the average, right? The mean. Is the mean resistant?
No.
Which statistic? Median was resistant, mean is not, and so what are we correlating that linear, that line that we could draw to?
Means.
The means, right? So is correlation resistant?
No.
No. So I think similar to mean. By the way, does anyone know what we call that line that's approximating those data points?
Linear.
Best fit, yeah.
That is a term for it. There we go. We're going to talk about a better term, but that is one of those introductory terms that we use when it comes to statistics, right? That line of best fit is a lot like a
I feel like
thing.
I've heard that before. Mine of best fit.
So, how about that? Is there a formula for correlation?
Yeah.
Yeah. R equals. Yeah.
That's
Notice.
why we have a
okay.
calculator.
Okay. So what is this right here? This is a value minus the mean divided by the.
Standard deviation.
So it's the value of x minus the mean of x divided by the standard deviation of x. That's just
So it's
the.
just
this
the
out.
That's a z-score of x.
How does someone figure this out? Like,
Same times
Phone.
the z-score of y. So for a single data point, it's the z-score of that data point times the z-score of that y value, and then we multiply them and add them all together. And then we're doing this weird thing of dividing by n minus 1. Why are we dividing by
That's
n minus 1?
degrees of freedom.
Because the degrees of freedom, because we are averaging them. We're just averaging them, right? But I will also point this out. So there's the formula. Do you need to calculate this by hand?
No.
Heck no, right?
What pops up on
I ain't doing all that.
Oh, wait, you have a calculator the entire time.
Ding, ding, ding! We got a calculator this whole test. It's not like calculus where you have a calculator and non-calculator portion, right? In statistics, we're all about that
I
calculator.
found out yesterday that on Chem, you don't get a calculator at
On what?
MCQ.
Really? That's wild.
You don't?
Okay. So, notice that formula. There it
From
is.
what I saw, you don't.
Make a note. You do not need to use a calculator. So, let's actually go back to this data real quick. Okay? Okay.
Calculator time.
Where do you, let's actually go back to 1.1 where the actual data was. How do you think I'm going to calculate that R using this calculator?
Menu.
So make sure you go back to the raw data. So yeah, hit that menu button. Then
Statistics.
statistics, stat calculations.
New variable.
Let's check under two variable.
Oh, never mind.
And then we might check under, what were you thinking, Austin?
Linear regression.
Let's check under two variable first.
Wow.
So X, what was our explanatory variable?
Handy. No, handy handspan.
I think handspan was. What was our response variable?
Candy graph.
Candy's grab, frequency list, 1, don't put a category list, and first result column. I think we already have something in D and E, so we need the first result column to be in F.
Well, we could just replace.
We can. Alright, so notice, right, we look at our two variable stuff. Make sure you go to the list and spreadsheets.
Oh, there is an R.
Ah, there is an R.
Go
So
down low enough.
yeah, so if you start here at the top, I'll give you a chance to do the calculations by hand, but I want us all to see this. The two variable gives us the mean of x, gives us the standard deviation of x, it gives us our sample size, gives us the mean of y, standard deviation of y, and there's our r. So how would we describe this linear relationship?
Strong.
A strong, positive linear relationship, right? It's a pretty strong positive linear
Wait,
relationship.
how do you determine? Oh, no.
Say again.
I'm good.
So we put it in F because we already had D and E, right? So just hit
Because
OK.
of everything.
So,
So far, so good.
I know, right? It's just pulling together all that we've learned. So notice minimum, and notice it gives you your 5-number summary of all these things. One detail I do want to point out is this. So let's check Bryson. So you don't need to do this, but I'm going to check Bryson's data. I'm going to take Bryson's data out.
The big board, right?
Okay?
Which one is his?
The one that says Bryson.
Kimbro.
Now, let's look at the correlation coefficient.
Oh, it changes? Real time.
Did it change?
Mm-hmm.
It changed that R significantly, didn't
Oh,
it?
never mind. That's pathetic.
So was Bryson's data point a high leverage data point?
Yes.
It was, right? It changed that R significantly.
Now they have pro Excel spreadsheet
Okay.
competitions.
So you don't need to do this, but I do want to also show you so what's another word for a line of best fit? We see it right here. A linear regression. We're going to talk more about that in the future. I'm going to use linear regression really quickly. I just want you to see handspan, candy grabbed. And I'm going to put it in.
We're still leaving out the budget?
I'm going to put it in F.
Just leave it out.
Are we?
Hey, just don't sweat it. So, hey guys, just right here, I just want you to notice, this time it doesn't give me all the means, but it does give me the equation. We're going to talk more about this equation later. Notice my A, my B, that's my y-intercept, that's my slope. Does it give me R?
Yes.
It also gives me R squared. We'll talk about that in the
Which one
future.
did you use?
Linear regression. It does not matter, but I use the A plus BX, and I'll tell you why soon.
Okay.
It makes for decent here.
Okay.
Regression was also on the mock exam. I didn't know what
Yep.
it was.
Not bad though, is it? So notice there's multiple questions that Austin didn't even have a chance to get right, but you do. I apologize, but
It's okay.
that's a good thing moving forward. Okay. So what are some additional facts about correlation? Let's see.
Not causation.
So correlation does not imply causation. Right here, I need you to pay attention to these details in red. Correlation does not measure what? Form. If you look right here, the correlation of this right here, that correlation is 0.98, which would indicate that it's a
Very strong.
Very
Strong. positive
Positive.
linear relationship. But look at that again. If I really trace those points, does that look linear to you?
No.
Looks exponential.
It does look exponential. So it's important to recognize that you have to graph the data and you have to check it and check the actual form.
Oh.
Do not just look at R, because if you were to look at just the R, it doesn't tell the full story, because if it's not linear, it still might spit out a really high correlation coefficient. So make sure that you are careful about that, because that has a really high correlation, but that's not a linear relationship. So don't you dare call it a linear relationship. Don't say strong. Don't say positive, because it's non-linear. Okay?
So if it.
So it's not linear and skip all that?
So you just can't.
What?
You would just say it's a
So what if it's a
non-linear.
bunch of random things? Is that also not linear?
So that's different. This has a very clear curve to it.
Okay. That's fine.
And we're going to talk about residuals, which you brought up earlier soon, and what's called a residual plot. So notice right here, correlation should only be used to describe a linear relationship. Please make those notes there under where it says what are some additional facts about correlation. So correlation does not measure form, right? Linear versus nonlinear, and it is only to describe linear relationships.
So we'll have to like that'll be on the exam. We'll have to realize that.
It's usually going to be linear on the AP exam, but I have seen one question on the free response where it was very clearly non-linear, and you had to be aware of that.
Is this the unit where the free response is weighted more?
No,
Is this the problem?
We're not on the last unit yet?
this is the last unit.
So what's the unit?
What's the
So
There's just one.
after this, there's inferences with this, which is literally like 2 to maybe 5%, and then there's chi-squared, which is 2 to 5%. So this is the last big unit, right? But it's not weighted that much more heavily. I think it's like 10 to maybe 15%.
Which one is like the AP FRQ like 6?
Yeah, what's not problem 6?
So question 6 is actually, so this is what you want to be aware of. it's going to be a mix of units, and it's going to be early on, the first like 3 to 4 questions, something you have directly studied, and then it's actually going to step you through seeing a new concept usually that you haven't directly studied.
That's great.
But it's applying, hold on, but it's applying what you know. Because like I want you to think about this, had you studied bivariate data yet? But you were able to apply what you knew to make sense out of this, right?
Yeah.
That's what question 6 does.
I suck.
I'm gonna have to do that tomorrow.
Oh, cry me a river. I don't want to have to think.
It might be easier.
No, I don't have to.
Alright, and correlation is not a resistant measure of strength.
Dog, I want my college credit.
So we already have-
Yeah.
Okay. Last couple of facts about correlation right here. Correlation requires that both variables be what? Both variables need to be quantitative.
Quantitative.
Okay. Both variables need to be quantitative. Correlation makes no distinction between explanatory and response. Okay? Correlation does not make a distinction between explanatory and response. And I want to look at this formula for why.
No, I think that's the formula for R.
That was funny. Why does correlation not care which one's X and which one's Y?
Because they're both going together.
Because they're being multiplied. Does the order of multiplication matter?
No.
No. Okay, so it does not care which one's explanatory, it does not care which one's... So like if I switch my X and Y axes, will it give me the same correlation?
Yes.
Yes.
Yeah.
I want you to also notice right here, and this is part 3, because R uses standardized values, does it care what the units are? So if you take feet and convert it to miles, am I still going to get the same correlation coefficient?
Yes.
So because we standardize the values of the observation, R does not change when we change the units. I've seen exact multiple choice questions ask about that on the AP exam. And the correlation has no unit of measurement. Please make sure you make those 4 notes. Okay? Yeah.
What's the easiest AP question you've ever seen?
Honestly, probably the first multiple choice question on the practice
I
exam.
remember there being some pretty easy ones. I just remember.
There was one, I had one on
Is
my
this a line
8s, it
of
was like the dumbest question.
Say again.
Is this a line for R?
You lock it in.
So please make sure you have those 4 things down in your notes. So you need all 4 of those.
One.
What? So we have all 4 written down? I'm going to take that as we have all 4 written down. Alright, there's some homework. Please notice you are now prepped for progress check A. I've already set it up to open. You do not need to have it done yet because we still need to take the test. Okay. Squared up task. I already passed this out yesterday. Okay. I've already passed it out yesterday. This is what we're going to spend the first part of tomorrow on. So are we on page 3 or 4 of the notes? No, you're good. We're only on page 3. Okay, so we're almost on page 4.
What's squared up? Is that the 4th?
It literally says squared up.
Oh, I dang it.
Wait, is it like, in our notes?
I handed it out yesterday.
I don't have it.
It's this one. Can't see it?
Both of them.
Squared up, right
You
here.
said it with the notes.
I handed it out yesterday.
Yeah, you did.
I wasn't here yesterday.
I know where that is.
Wait, what have you been writing all your notes on this whole time?
All last unit's notes.
Oh my gosh! You stress me out with your life
All the words
choices.
are there.
Dude, you could have
Squared it up.
asked.
For real.
It's right there.
Here's squared up.
wondering why his pages
Looks so different. I gotta find the notes pages for you, but here's the Frere model. You
Why
got
do your
I
that.
didn't get a fair one.
Nothing like
Man, Joseph. It's a good thing you're as smart as you are. Alright, so tomorrow we're going to pick up with this squared up task, okay? So, hear me on this. I want you to go ahead and understand what the point of this lesson is. We already know that the line of best fit is also called a what? A linear regression line, okay? The proper name for it in the AP statistics world and in general is called a least squares regression line.
So good.
I know.
But
But,
abbreviate that.
well, we usually say LSRL, okay?
Beautiful. Great.
But least squares regression line. And we need to understand what in the world we mean by least squares, because there's lots of lines you could draw, right?
Yeah.
But is there going to be a best one?
Yes.
Yes. And that is called the least squares regression line. This task is going to help us understand what residuals are, how to calculate residuals, and those play a huge part of understanding standard deviation with these lines, things like that. So, and then after we finish that, we're going to do the horsepower lab. So, wear some shoes that you can run upstairs with.
Yo,
That's tomorrow.
I do
I wear my
cardio like
slippers.
twice a year.
Then we gotta go more.
So reduce
I
compounding, we all
I
run
can't-
barefoot.
Sounds like a bad idea. Wear some shoes you can run in, okay?
We should all
Tell
go buy
Bryson,
the
tell-
Scatterplots.
hey, someone put it in the group message so that Peyton, Haley, and Alyssa know. Hopefully they
Wait,
won't.
is
Right?
tomorrow? It is tomorrow?
Hey, go.
Tomorrow is when we should do
I'll wear
it.
my running shoes.
Okay, who needs a few extra minutes to work on their demonstrate your understanding?
Bye.
Logan?
Stairs.
Go ahead and
I was
finish
gonna
this
throw
up.
that dominoes and go for the
I don't.
Go do my
This is
last.
Austin,
Sir.
Ashton,
Deacon, are you doing that like, what is it, scholars?
giving you a few minutes to
Oh, yeah.
Lexi.
Taken.
There.
Langford.
Lexi.
Lexi, I don't know why I was trying to hand it to you. So fun fact, Tyler, you asked and then Deacon comes up to me like 30 minutes later.
Like dog. And then Aiden already asked me